Hey everyone, welcome to another video. Now, just to wrap up our Year 9 linear relationships topic, we are just going to start talking about this idea of simultaneous equations. Now, what we mean by simultaneous equations, the kind of easiest definition of this is just two equations that occur at the same time. That's pretty much all we mean by those. So, simultaneous equations is just two equations at the same time. So the idea of something happening simultaneously is two things happening together at the same time. Now, before we even talk about how to solve these, how to graphically solve these, which is what we're working up to at the end of this video, let's just take a minute to consider two lines here. Now, say I draw one line looking like this reddish line. Now, if I were to start drawing another line, for example, down here, is this line eventually going to meet my red line? Well, just looking at its orientation, if I keep extending it through, yes, it will meet my line at this one point here. Now, is it going to meet it again? So if I, for example, kept extending this here, if I kept extending my red line here, or in the other directions, we can see pretty clearly, or they're never going to meet again. They're always meeting at this one point. We can just call that point XY, this one here. So both of our lines, and this goes for most of the lines we're going to encounter, they're always going to meet at one point. Now, let's consider other lines in another orientation. So let's say one that goes like this, and some other line starting up here. Well, we keep drawing that down all the way through. We can see once again it meets at this one point here. And these lines will never meet again because they're just going to keep shooting off in different directions. This one's going to keep going down here and up here. And we can see pretty clearly this light blue line, it's always going to be going away. They're never going to meet again. And what we're doing when we solve these simultaneous equations, and especially graphically, what we're doing is we are trying to find this point here. So this point, I've just arbitrarily put x, y to show an x coordinate and a y coordinate. But what we're doing here is we are trying to find this point. And a really important idea here is that this point, this intersection point, lies on both lines. So this particular point xy, if it lies on a line, it satisfies the equation of both. Remember, we've talked about this earlier in previous videos, but if a point lies on a line, it is a solution to the equation. It is a point which, when you put in the x, you put in the y, it makes the equation true. So I'm actually going to write that down here because this is pretty important. The point xy lies on both lines. So in other words, it satisfies both equations. By that, I mean, once again, if I put my x coordinate, my y coordinate into my equation, the left-hand side will be equal to my right-hand side. Now, let's just quickly think, is there a case where we have two lines that don't meet at a point? So if I had yx here, most lines, even if they're in the same orientation, so this one and say this one, they're kind of not really obviously crossing just yet. If we extended these lines further, we would see that eventually they're going to meet at a certain point. But there's one type of relationship between the lines that says that they will never meet, that they're never going to meet at a single point. Now, some of you may remember the definition for these. These are what we call parallel lines. So, parallel lines, we cannot solve using simultaneous equations. So we're going to see that a little bit later, but parallel lines don't have this point xy. So I'm going to write here, doesn't work for parallel lines. Okay, I've talked enough to give you guys hopefully a good intro and some of the intuition into this, but let's talk now about, well, let's actually just jump straight into some questions. So we're going to start with question 1, and here we are checking the intersection point. So what we're doing here is we are going to be given two equations. So this is y equals 2x plus 3 and y equals minus x. And we're going to check this with the point minus 1, 1. So what we're going to do, we want to check if this point here is an intersection point. So is it going to lie on both lines where they meet? And how are we going to check that? Well, you may remember before we talked about this idea of if a point lies on a line, it satisfies the equations. So if I put this -1 here in my x and I put my 1 here in the y, and I do this for both, I will get this being a solution to both. So if this is in fact an intersection point, then when I substitute x and y inside, then the left-hand side of the equation of both is going to equal the right-hand side. Now, let's actually just jump straight into working with this. So we're going to check y equals 2x plus 3. So what I'm going to do is I'm going to substitute my 1, my y coordinate, into here. And I'm going to substitute minus 1 into my x. So we have 2 times minus 1 plus 3. And we're going to check, well, does the left-hand side equal the right-hand side? Well, this 1 on the left-hand side, we can't really do too much with that. But on this right-hand side, these brackets and how this is written algebraically, this is a multiplication. So we're saying 2 times minus 1. That gives us minus 2 plus 3. And minus 2 plus 3 gives us 1. So that's good. Our point -1, 1 satisfies my first equation, which means the point lies on the line. So that's really good. That tells us, okay, this is a point on the line. Now we want to check, is this a point on the other line? So we're going to substitute that in now. So we're going to say check y equals minus x. And I have the point -1, 1. So I'm going to say, I'm going to put my 1 into the y and my -1 into my x. So I have minus 1. Just check I've done that correctly. Yes. So Here I have on my right hand side negative lots of -1. Now here I have a double negative here. Now when I have two negatives multiplying by each other, that gives me a positive. So I will get +1. So this point lies on both lines. So that means when we draw our thing up, for example, like up here, our point lies on my green line as well as my light blue line. This is just an example, right? But by finding a point that lies on both lines, we are finding the intersection point of both lines. That tells me where these lines are going to meet. And what we're working up to by the end of this video is solving these things graphically. So we're going to graph two lines and try to figure out where they meet. Now, right now, we're just trying to understand how intersection points work with this first example, and we're going to look at one more example just to see what happens if it maybe doesn't lie on that line. So we're going to check if for the lines y equals -2x and 3x plus 2y equals 4 for the point 2, -4. So my x coordinate's 2, my y coordinate is -4. So let's check for my first equation. So we're going to check y equals -2x. Cool. So my -4 goes in my y, and my 2 goes into my, it's getting substituted for my x. So -2 times 2. Now, -2 times 2 gives me -4. So this point, let's do that in a different color. This point, 2, -4, lies on the line y equals -2x. But that's great. We know that. But to check if it's a point, or to check if it is in fact the intersection point, it has to satisfy both this one as well as this one. So we have to check this second one before we can say anything about it being an intersection point. Right now, so far, we just know that our line, our point, lies on my first line. So we have 3x plus 2y equals 4 as my other one. So that's what I'm going to check. I'm going to check 3x plus 2y equals 4. So once again, I'm substituting in here. So I'm going to put my 2 where my x is and my -4 where my y is. So that's going to give me 3 times 2 plus 2 times -4. And we want to see if that equals 4 on the right-hand side. So 3 times 2 gives me 6. So we're adding plus, and then 2 times -4 gives me -8. So I've got plus -8. In other words, this is like saying 6 minus 8. And when I subtract 8 from 6, I get -2. Now, -2 does not equal 4. So if my point, when I sub it in, does not satisfy my equation, it does not lie on this line. So my point doesn't lie on this line 3x plus 2y equals 4. So this is definitely not the intersection point because it's not even a point that lies on this line. So we can say, therefore, 2 and -4 is not an intersection point because it doesn't even lie on one of the lines. It's a point on one line, but not a point on the other. So there is no way we can have this as an intersection point. Remember, guys, if I scroll all the way back up here, the intersection point has to lie on both lines. And the way it lies on both lines is it has to be a solution to both equations. Not just one, we need it for both. Okay, so this next bit, this is all that we've been building up to. We are now going to try to solve these to actually find the intersection point graphically. In the previous examples, we were just checking intersection points. Now we are actually looking in this next question at solving, all right, SEs, simultaneous equations, graphically. Okay, so we want to solve the equations y equals 2x minus 2 and x plus y equals 4 graphically. So what do we have to do first? Well, these equations in their current form don't help me, right? I need to actually draw this in order to be able to see if these lines cross. And to do that, I need to actually draw them quite well. So I'm going to use these grid lines and really try to get a sense for the exact point where these two are going to meet. Now, let's have a look at finding first a way to sketch out this particular equation here. Now, in a previous video, I looked at a strategy for sketching these by finding x and y intercepts. So that's what I'm going to do to sketch out this first line. So my y-intercept, so I'm going to write y equals 2x minus 2. So my y-intercept, if we remember from our equations of our lines, y equals mx plus b, this b is our y-intercept. So I can just read that straight off. Or I could have also substituted x equals 0, but my y-intercept happens at y equals negative 2. So the negative 2 on the y-axis. And for the x-intercept, I'm going to let my y equal 0 in order to solve this. So I'm going to, this should all be a revision, guys. If any of this is unfamiliar to you, please go back to the previous video. I'm going to put in 0 for my y, and I get 2x minus 2. And I want to solve this equation. So I'm going to add 2 to both sides here to bring this 2 over to the other side. And I get 2x. So what value of x satisfies this equation? Well, 2 times what gives me 2? That what is 1. So x is going to equal 1. So I have my x-intercept, my y-intercept. Let's find it for now this equation here. I want to find my x and my y-intercept. Well, let's find my y first. So, all right, so for this equation, x plus y equals 4. I'm going to find my y-intercept by setting x to equal 0. So my y-intercept, my x is going to equal 0. So this number here, I'm going to substitute 0 in for it. So I get 0 plus y equals 4. What number adds to 0 to give me 4? Well, 4 does. So y is going to equal 4. And finally, for my x-intercept, my y is going to equal 0. Now this is just simple finding intercepts and sketching. So it should hopefully all be revision, but putting in 0 for y here, I can see that x plus 0 equals 4. So x is going to equal 4. But let me write that out as well. So x plus 0 equals 4, just to show my working. So therefore, my x equals 4. So now I have all of my intercepts, that I need to draw my graphs here. Now let me just draw a really nice grid here. I'm going to be very careful to make it to scale because that's going to help me a lot. So let's do it like this here. 1, 2, 3, 4, 5. And I have 1, 2, 3, 4, 5. Please feel free to skip if this is too monotonous for you. But I'm going to -1 and -2. That's probably all I need for now. And making sure I label my axes so I know what's what. Okay, so drawing my first line, y equals 2x minus 2. My y-intercept for that is -2. So my y-intercept for that is -2. My x-intercept for that is 1. So this line is going to look a little something like this. Let's go back down here. So this is my y equals, was it 2x plus 2? Oh, 2x minus 2. Now, I want to sketch my other one, x plus y equals 4. My y-intercept is 4. My x-intercept is 4. So my y-intercept is 4 and my x-intercept is 4. And this thing is going to, when I connect these two together, here, 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 that is this line sketch. So I have x plus y equals 4. And you can clearly see there is one point smack bang in the middle where these two meet. And now we can just figure out what's the x-coordinate. Well, if I draw down to the x-axis, my x-coordinate's 2. And if I go to my y-axis, my y is 2. So my intersection point is 2, 2. And that is how we can think about solving simultaneous equations graphically. We just need to graph it using whatever method you'd like from what we've covered in this video series and the one from year 8, linear relationships. And once we graph them, we will always see these meet at one point. And if we have a nice grid drawn, good scaling, and our lines look good, we're going to find a pretty clear-cut point where both of these lines meet. But that's it for this series in Year 9 Linear Relationships. Thank you so much for watching, guys, and I will see you in the next one.